What really happened with the Kaveri engine, and is it too late to revive the Kaveri?
Kaveri had went for its high altitude trials to Russia. But the problem was that every trial took about a year. As a matter of fact, this is one of the reasons that caused the delay in the Kaveri. Nothing to do with the people who are working on it. It is just that we didn't have the required test facility. I mean, any aircraft engine will take you 20-25 years if you're starting from scratch to develop. They set up a committee to see how we should proceed. To say there were delays when you know that you don't have a high altitude test facility, you don't have this. They said no, a GE404 is the only option. Net result of that was that Kaveri program was to be closed.
Do you think that we should build up our technological capabilities from scratch?
Definitely.
Or go through the saffron route?
Even having done that TOT, for the areas that you did TOT with the other person, you better start building your own capability in those areas also. If the naval program today is working, it is because of two reasons. A, we have not gone through the TOT route. B, we have specialized manpower available for the purpose. Though the numbers are very low, greater numbers, greater funding available, you do much better. But that's for all design organizations.
Right.
Even DRDO, the problem is the same. I mean, laboratories today are at half the strength to what they were during Abdul Kalam's time.
Why is this this blindness when it comes to technology development?
Somewhere in the decision-making circles, there's not enough appreciation as to what R&D is all about.
Hello and welcome to the Sandeep Unnithan Show, your weekly dose of defense, geopolitics and much more. Today I'm privileged to welcome back on my show Vice Admiral Raman Puri. Admiral Puri was former Chief of Integrated Defense Staff, a long-time votary of Made in India as opposed to Make in India, and of course IDDM, indigenously developed, designed, manufactured systems. Admiral Puri, welcome back to my show.
Thank you so much.
We were talking about engines, Admiral Puri, and I was asking you about the Kaveri engine. Every discussion about jet engines in India begins with the Kaveri engine. What really happened with the Kaveri engine, and is it too late to revive the Kaveri?
I think I'll go back to the history first. I was in the chair as CISC in the year 2003 to 2006, early 2006 actually, not much of 2006. Somewhere I think in 2004, 5, 6, there was talk of the Kaveri not doing well.
Right.
What had happened was that Kaveri had gone for, I may be off in my thought of years, because now it's 20 years past. Kaveri had went for its high altitude trials to Russia. And this may have been the second or the third trial they went, and the problem was that every trial took about a year. You had to first pack up the whole thing,
Right.
do custom clearance here, do custom clearance there, wait for your turn to get a trial, do the trial, and even if there was a minor thing to be done, you get the engine back here, start working on it. So I don't know which iteration it was in. As a matter of fact, this is one of the reasons that caused the delay in the Kaveri. Nothing to do with the people who are working on it. It is just that we didn't have the required test facility.
High altitude test facility.
You require two types of tests. One is high altitude test facility, then you require a hack aircraft.
Right.
Which can actually take that engine to those engines and prove it to you.
Would this be like an IGM DP without a Balasore or a Chandipur on?
Yeah, I'm on to the same. I'm on to the same. You see, we talk so much about joint venture and all that.
Right.
Boeing, because of some purchase we must have done, whether it was civil aircraft or other, was committed to give us a high altitude test facility set up in the country.
Right.
And Nagarjuna Dam, because a altitude test facility requires a lot of water.
Right.
I mean, it's some lakhs of gallons per second it evaporates. And that's how that whole evaporation really produces the cooling. But they backed out. So all this thing called offset
Right.
That offset didn't work.
Hmm.
Anyway, well, that's history now. So we were fixed to go to Russia.
Right.
In the final trial, when they went, what happened? The dry thrust engine, this is in about 2005-6, the dry thrust engine was okay. It was developing, I think, about 46 kilonewton, where it should have developed for 49 or 50 kilonewton. And that was not a great deal. It required some fine tuning. But there was a problem with the wet thrust engine that it, as against the rated 72 kilonewton, it was, I think, about 10, 12 kilonewtons less than that. GTRE said, basically, we understand the problem. They had done a lot of due diligence on this, and with an OEM, and but by this time, I think there was impatience in the whole setup. So many years have been taken. Not
Which
real
setup? You mean the user? The
No.
Air Force, the DRDO?
Well, I would say in the system.
Right.
Not DRDO. DRDO was working at it. Between the Air Force, the ministry, I mean, there were impatience or whatever you may call it, I don't know. To say, so many years we have been working on, what you have been working on?
You only worked on it until 2009 or so.
I mean, any aircraft engine will take you 20, 25 years if you're starting from scratch to develop.
Right.
Thereafter, fine-tuning, all this will take place. But, and whatever be the case, we won't be in the situation we are in today. If you don't stop, you continue with the Kaveri program, we would have done a 72 kilonewton, gone up to 90 and 100 kilonewton also. And the fundamental issues in an aircraft development are its control systems. Yes. In the engine development is its FADEX, its low boil system. All those are the fundamental things which they were practically solved at 62. It will be solved for other things also. So, but net result of all this is that we are in the situation we are in today.
And what is the situation to your mind?
So today, the situation is that because the funding was stopped, and I think DRDO's chairman's powers were small till about, I think, 4 or 5 years ago, when they have been increased to something like 300 crores. At that time, this is my guess, I am not very sure what happened, that at that time DRDO has funded the development to get one prototype made through industry, where the industry will get involved with the GTRE and understand the requirement of components and all that, get manufacture many of them through an ecosystem that it sets up, and all that. So this way they got an engine developed between GTRE and Godrej, and I must say Godrej did a wonderful. I visited Godrej and seen this facility. They have done a wonderful job. There's no denying of the fact. So this engine was built with, we are now capability to get to about almost 85%. There will be some material which we don't have and all that. So if you take those percentages, it will go up to about 90% will be an indigenous engine, but nothing as critical as the FedEx is not available or low boil system. All those critical systems have been done, and there is an industry which has done all these systems. The second thing I would say is that this industry, I think then the MOD was approached and another grant got, I don't know how many crores, for them to produce 6 prototype production grade engines.
Dry thrust.
So those engines have come up. I think some have already been delivered and they are doing well.
This is for the Ghatak UCAV.
For the Ghatak, it will be
right.
But
so the Kaveri as such, in the configuration that it was meant
I suppose, I really don't know the present state, but I'm told that some work is going on.
Right.
But even if you produce a Kaveri today, I mean, will you remodify and if you remodify and fit this engine in, I mean, those are things I really fit this engine. There will again be a certification issue, which will not take less than 4 years.
Right.
So we have to have, in my opinion, we now need to do this, Kaveri, to prove it. You can prove it in one LSP or some aircraft. Prove it. I'm not saying no. Do your
An
tax.
LSP, an LCA,
LCA
Mark 1.
Mark 1 में डाल के इसको prove करो जितना कर सकते हैं.
Right.
I do not know the mechanics of how it will be done.
Right.
But if I was to think about it, I mean, I would still, if it works, I will run this LCA with the 72 kilonewton.
With a derated
I mean, whatever
engine.
it is, that is 76 ultimately.
Right.
See, in some analysis that I had been involved with one ex-designer in the GTRE. He's no more in the system. He resigned, I think, about 6-7 years ago. He said that, look, at ground level, there'll be no difference in performance. As a matter of fact, at ground level, with the Kaveri as it is, the aircraft will perform better. At about 3,000 feet, the performance will be equal. But when it goes up higher than that, say 30,000 feet and all that, beyond 10,000 feet, then the degradation will be about between 5% and 10% in performance.
Right. So you're saying that a limited series LCA is possible.
So I said, even if you get, I do not know the mechanics of how they're going to achieve it.
Right.
But if it was giving me 72 kilonewtons and you're getting 76 out of the GE today, maybe we can see subsonic performance, which is most of the performance of the aircraft, is with the dry thrust only. I mean, wet thrust is only used when you want to go. But that is necessary. I'm not saying it is not necessary. You have to get away and all that. You need your wet thrust. But I suppose the aircraft can still go and fire a long-range missile. Nothing stopping it. You're doing it from your own territory. You're not meeting the other guy. So you can still use it. But anyway, these are speculation. To get the right performance out of an LCA Mark 1, you need about a 90 kilonewton. I mean, if I was to do it today, I would develop a 90 kilonewton Thasker engine. And in my assessment, then, see, you take the numbers. Between LCA Mark 1, LCA Mark 2, and the first 6 quadrants of, I don't know how many, AMCA, you're totally a group of something like 500 engines, isn't it? 500 aircraft.
500 aircraft, which will require
which requires engines over their lifetime.
Right.
Now, if this is half your Air Force. Half your Air Force is just this. LCA Mark 1, LCA Mark 2. And in time to come soon, there'll be a time when Mirages will go. All these aircraft, they have been there for a long time. But I suppose we'll continue with them till we have to. But fact is, this will amount to half your Air Force.
So we were speaking earlier before the show, and you mentioned that you actually need multiple engine programs.
I agree with you. So I personally feel if I have, the quicker we started, the better. I have a 90 kilonewton engine program for which all material, everything is available. We know what to do. We don't require any JV or anything for it. And I don't think we will require it even for a 98 kilonewton, 98 to 100 kilonewton, which is LCA Mark 2's requirement and the AMCA's Mark 1 requirement. So one program 90, other program 98. Now, whether you can develop a 90 kilonewton and in the design itself make provision for it to be upgraded to 98, I'm not a technical person, I can't tell you. But definitely we need a program to produce a 90 kilonewton, to produce a 98 kilonewton. The mechanics of producing it will be, one can think about. I mean, can I produce a 98 kilonewton and then do the derating part of it in the design itself to bring it to 90 kilonewton for, I do not know. But these programs you require. I need a 90 kilonewton engine, I need a 98.
Because these are your workhorse engines.
These are two of my workhorse engines. Then 124 kilonewton.
Which is your AMCA class.
Which is, now there is, I'm thinking a lot of, I don't know what stage the joint venture is in today. But if they have already entered into a joint, proceed with it. But I would still, if I was, my own view would be, I would still do R&D on key parts of that engine. I'll do R&D. so that my own domestic technological readiness level in those areas at least goes up to 4, 5, 6. So that I'm, even in a joint venture, I'm sitting there as a very knowledgeable person.
Right.
The more knowledgeable you are, the more you will contribute to that joint venture. In the joint venture, I suppose certain things will be our responsibility, but certain things will be his responsibility.
Right.
But in whatever be the distribution of responsibilities, I think we should, those areas which may not be in my part, but maybe in the other person's, we should still do R&D to know what.
And not
And
make
raise our technology level and
Right.
not in this area, not be, okay, you give me and I will fix it. That's
Right,
only.
right.
I mean, I may even do joint work
Yeah.
with them. I really don't know what are the parameters of this.
Right.
But 124, when is the MCA Mark II coming? Where is it? What are I don't think there are even sanctions given for it, is it? Any work starts? I mean, aircraft design, even if you, because of the engines that are already there,
Right.
I mean, the work that has already been done, you may not take the full 20 years to develop that engine.
Right.
But I don't think 10 to 15 years has gone anywhere.
Right.
To be able to एयरक्राफ्ट को डेवलप करना, इंजन को डेवलप करना, फिर उसका सर्टिफिकेशन करना, इट्स एटलीस्ट 15 to 15 year program, or
15-year program.
I can't see it being less.
Right.
So we need actually multiple engine programs going on in the country. We need also to seriously set up our high altitude facility.
Yeah.
And get a hack aircraft. Hack aircraft we should get in any case.
We don't have it yet.
We don't have.
We're still nirbhar on foreign suppliers.
Yeah, as of now, yes.
Right. What are India's actual gaps today, sir, when it comes to building a jet engine? Is it the hot section materials? Is it the FADEC? Is it high pressure turbine?
I'm looking at it. This materials, especially the hot parts.
Yes.
I think that's. But up to 80 kilonewtons, I think we are okay. 80 and even 85, we would be probably okay. Beyond that, I know some years ago, I mean, not within the system, but outside the system in think tanks and all that, we were just sitting and talking. The cost will be about 6,000-7,000 crores to develop those materials. Right. And something may have already been done. I mean, after all, DMRL is not just sitting quiet and doing nothing. So a lot of things may already be there.
Right.
So I couldn't tell you what is the current state of material development.
Right.
But these are generally the areas where we falter. It's in the hot parts. And then another area is the single crystal blade.
Right.
But we have got directional blades. Only thing that you suffer with the directional blade is that the life of the directional blade is half that of a. So instead of lasting for 8 years, it probably last 4 years. But I would say that with my back to the wall, I'll accept that.
Directional blade.
Directionally solidified blade, that technology exists. Right. Single crystal blade, I do not know where we are.
So, do you think that we should build up our technological capabilities from scratch?
Definitely.
Or go through the Safran route, like a TOT with Safran?
I see, TOT business is fine, but even having done that TOT, for the areas that you did TOT with the other person, you better start building your own capability in those areas also.
TOT doesn't work.
No, TOT, my own view on TOT has been that it's all right in the initial stages to get something through, but nothing like, I mean, if the naval program today is working, it is because of two reasons. A, we have not gone through the TOT route. B, we have specialized manpower available for the purpose. Though the numbers are very little. With greater numbers, greater funding available, you do much better. But that's for all design organizations. Right. Even DRDO, the problem is the same. I mean, laboratories today are at half the strength to what they were during Abdul Kalam's time.
What is the reason?
I mean, somewhere I think It was in 2010, 11, I don't remember. Some, there were manpower freeze all over the country, including all the design organizations. There were, but that freeze has never gone. I mean, then if somebody retires, you take one more, and some you keep putting up cases, and you get piddly little amounts. I remember doing the long-term technology plan for DRDO, and at that time I had estimated they require at least 3,000 more scientists for the projects that they were doing.
So they're understaffed.
But definitely, all laboratories are understaffed.
All design houses are
I mean,
understaffed.
we have shut down some laboratories. I would never shut down Anurag. It is, I mean, if you shut down Anurag, your processor requirements, at least they had the knowledge in that area was building up. No, it will take time. Then we shut up Lastech, which, I mean, today you have developed laser systems, but the technology from them started there.
Right.
And I met one scientist who had retired, personally literally crying. He said, "Sir, we would have been at a much higher value today, but for that laboratory having been shut."
Why is this this blindness when it comes to technology development or this manpower thing? Is it because it's a one size fits all for everyone, every government organization?
I really don't know, frankly. To me, I can only say what it should be. Why it is not like that? I think somewhere in the decision-making circles, there's not enough appreciation as to what R&D is all about. R&D is not, information technology is not the only R&D that we do where there are youngsters doing.
Right.
But even those youngsters require mentors. Right? No R&D works without a mentor.
And that's the biggest, one of the biggest contributions of scientists.
By having the retirement age fixed at 60 for scientists in DRDO, or I think in other major organizations, we are losing. I mean, I remember when I was when I was running my ship, and we had a problem, and we used to call for Russian help. And the people coming were 70, 80, white hair all over, but the brain was ticking.
One of the Soviet-built ships.
One of the Soviet-built ships. I mean, we had some systemic problems. They would come and to resolve them, they had to send from their design bureaus the people to solve those problems for us. But they did it. But the people were knowledgeable. They were solving mathematical problems while they were doing the thing with us. So my point is that what manpower is required in the design organization is one thing. The Department of Atomic Energy, see, they have a regular intake of human beings coming in.
Right.
DRDO for, I think, good 7 years had no intake.
Right.
They resulted in a situation there were more scientists G's and F's than scientists B and C.
Right.
The net result of that, when you create such this, even if I start correcting today, it will take time. But I don't see the corrections taking place, frankly. Right. But I would say that now the only way is, there was a Japanese paper I was reading. It was called India Technology Evaluation. Who produced it, I can't really say. It was there in the net for a very short time. And the paper, he says that please increase the retirement age of all DRDO scientists to 65 years. And for some, you may increase it to even 70. I mean, if you require some 70. Then induct 1,000 of people at the junior level straight away. I mean, so if outsiders can see this and they're right about it, I don't know why we can't think about it ourselves.
You mentioned earlier about the naval programs, and this has been one of my thrust areas as well, is that I see a problem in the way the engine programs are structured, the advanced technology programs are structured, and you have an in-house program, the Advanced Technology Vessel Program, which is driven by the Indian Navy. 90% of it is by the Indian Navy, a very unique organization.
So you see,
is that the answer for the engine problems?
No. Let me put it this way. The program is The program management is by the Navy.
Right.
Right? Management. But the program is run under the DRDO.
Yes.
The processes and procedures for their financial requirements, their decision making, etc. The are today, if you ask ATVP to, I worked in the Navy also. If I was to run this program from a directorate in the Navy, it won't work.
It won't work.
It won't work.
Why not?
It's difficult to work it. Then if I used to start going to the IFA of the Navy and then start doing the things, or you just had it. It won't work.
So this was structured 40 years back, knowing all these problems.
No, it was structured very well. And the decision making here, being a program of its nature, the decisions came very fast.
Right.
Decisions came fast. I remember having gone to this program. This is a program. One great thing in this program was that they took it on themselves to say that if we will take all care to select a vendor.
Right.
But once we have selected a vendor, if he fails, I also fail.
Right.
Here it is, you have failed, you have done this, you have done that.
So it's basically a partner rather than a vendor. It's a development partner.
Yeah, it was a development partner approach that has taken this program forward. There are many good things. One has to learn actually in VIF, I wrote there are two studies available. One is Make in India through R&D.
Right.
By DRDO / industry. The next I called Self-Reliance through R&D. It is part 1 and part 2 actually. Only when I first wrote the report, I called it Make in India.
Right.
By the time I was writing the second report, it was I think 2015 or so. And this word Atmanirbharta had come in.
Yeah.
So I changed the title of this to Self-Reliance.
Right.
A Prime Minister has got a great vision.
Yes.
Atmanirbharta. But the system below also must know how to convert this vision into a practical.
But coming back,
the system below, I am afraid, doesn't know. You leave it to everybody's got an opinion, but opinions don't make opinions don't make judgment. So my view is that we definitely need, rather than joint ventures, we need to be doing what is called indigenously designed, developed, manufactured.
IDDM.
IDDM.
Right.
But IDDM can't have a provision to leapfrog technology. You may do joint ventures.
Joint ventures don't work, to your mind?
Definitely not.
Not
joint venture. See, point is, doesn't give you any self-reliance.
Right.
You will get a system.
But the BrahMos is a joint venture, isn't it?
BrahMos are different. Joint venture A with the DRDO.
Right.
Where there were scientists dealing with scientists. But joint venture, when it comes to the services, then you're not dealing with scientists. You're giving you you're dealing with manuals. And the reason why simultaneously a lot of indigenization could take place, because the specifications and all that, there were designers who were looking into the whole thing.
Right.
Even today it is produced that way. So it was system designers who knew you see, to be able to develop a system or to design a system or to give a specification. For example, in the I have worked with the ONGC for some time as their security advisor. I'm very keen to know how billion-dollar programs come up in time. And the key to that was they had 2 institutes just to develop specifications for what they want. 2 institutes in ONGC used to be working to develop specifications for what they want. That's the difference.
So how would you structure an organization for these high technology projects like you mentioned, multiple engine programs? Are you talking of one authority that...
I agree with you, but for RADA there will be no LCA.
Right.
But for ATVP there would be no
Arihant or
No,
and its
no,
successors.
no nuclear submarines.
Right.
Right. So you definitely need project organization
Yeah.
when you have complex problems to deal with.
Right.
Right. You definitely need project organizations. Now, who is to drive them? Is a question of where does the domain knowledge lie? Domain knowledge in design and development lie. I mean, at least the project organization should have an understanding.
Yeah.
And of that.
You're not in favor of a user-driven approach?
No, I'm not saying nothing against user driving it.
The Air Force
Yeah.
driving this project, for instance.
I mean, frankly, I won't be able to comment on it. It's a question of whoever has to be able to, for example, ADA does design of aircraft, isn't it? So design of aircraft is the person must know.
Right.
But I don't say you couldn't have a good project manager, but he would have to probably be in this stream for some time. It can't be that I am a CNC one day and the next day I'm driving this program.
So you're saying you need to be an aircraft designer, you have to be like a ship designer. You're a ship designer, therefore you drive a ATV.
You are a ship designer or
a submarine designer.
A submarine designer or something. I mean, if you see the ATVP, the design, there have been constructors.
Yes.
And there have been electrical engineers.
Right.
The proper electrical engineers driving that program. And so there are two major elements. And the ship and the design of the submarine itself has been done by the Ship Design Organization, SDG. The weapon systems design and development has all been with DRDO.
Right.
It is this project organization which has been able to bundle everybody.
Right.
But then you require knowledgeable people there.
You're saying that the Air Force...
They must have an understanding of how a system engineering takes place from TRL 1 to 4 and 4 to 9. How do you take this whole system and button it up?
Right.
Somebody in ATV will be better to talk about it than I can. But why the whole structure is very different from anything that is there elsewhere. Right. Here you have there are people who are designers who have managed the organization, and there have been our electrical system engineers who have managed this organization.
Right.
So and for training and there is a wing for training, which is manned by the submarine. There is a good submariner over there who is looking after as to how the training is to take place. So my view is that yes, they can be designed and done, but there must be people with the right type of domain knowledge put in place. Now, I don't say Air Force doesn't have them or the Army doesn't have them, but if that can be done, by all means, drive it. But even then, both these programs are working because they are with the DRDO.
Right. You're saying that they wouldn't work if they were driven by the services.
It would be difficult. If they are with the services, it would be very difficult.
Right.
The method of sanction, the way services are designed to, a naval headquarters is designed to run a navy.
Yeah.
To be able to define what they would want day after tomorrow. Right. They're also designed to they're to operate the Navy, to logistically support the Navy in terms of material, everything. I mean, that's the major task.
Right. But then you also have ship designers, submarine designers, VESI, you have all these specialist organizations.
VESI is funded.
Yeah.
But that's where the chairman of VESI is also in DRDO only.
Right.
Okay. So just see the manning structure of VESI.
Yeah.
A person goes there, he remains there for 5 years.
Right.
Or 6 years even. And I think the Air Force has got an equivalent organization called the Software Development Group. I don't know what their task is, but they're trying to. But VESI is much larger. They can design, develop, and think. Command and control systems, for example, VESI is excellent at. But that is what there has been.
Right. So you do need a change in the kind of organizational structure to drive these projects.
to produce complex systems,
Right.
should I say. When you want to produce complex systems, you need a good project organization to drive that system. For example, every major project in DRDO today is being run by a project manager. There's a project,
Yeah.
PD this, some PD this thing. Although, frankly, the powers they require, the manpower they require is nowhere near what they should have. I mean, I'm making a statement. I feel the powers that the project manager should have, the type of financial controls that are exercised on them. I mean, once you have sanctioned a project, for each line in that project, if I have to go back to a FA to say yes or no, then I mean, financial powers required of project managers to run a major project is very different than what we give them.
So you're calling for sustained, ring-fenced budgetary support, which is not caught up in this budgetary.
Every major program in the US, for example, has had both time and cost overruns.
Yes.
They have been in billions of dollars and multiple years.
Right.
But you read the government accounting officer report.
Right.
Nowhere are they castigating everybody.
Yeah.
Audit objection, why has this not been completed?
Yeah.
They try to understand.
Right.
And they say that, yes, a hypothesis went wrong.
Yeah.
So there's no change in hypothesis being made. I mean, you really go into as to, I mean, after all, they were not fools working over there. Things can, but to start putting audit objections because things are not completed, then I think you're going the wrong way.
How do you build a specialist propulsion engineering cadre that will run this program for 15, 20 years? Because human resources are so important, as you
I said human resources are very important. For the immediate future, I would just take back the designers who are available. Not necessary, they may be in industry, they may be in academia, जहाँ से भी आपको designer मिलते हैं उनको ले लो. But most of them will come from GTRE itself. Or there'll be somebody in National Aeronautical Laboratory. For example, flight control systems and all that, Aeronautical Development Establishment, the National Aeronautical Laboratory, they've done yeoman's work.
Right.
But, and now they know what it means to design. Your missiles are being designed. I mean, they all require the systems that have been set up in the missile systems. If you see, they have not come overnight.
Right.
They've taken a good 3 decades to build. Today, that's why you can see every day I hear, ये missile launch हो गई, फिर वो missile. Today they can go into the system where they are fairly reasonably clear that the system will deliver.
Right.
It will meet the objective. So all this has to come. And my only view today, where I fear about, is that we are losing the mentor part of our research, especially in the DRDO, at a very fast rate. People are retiring at the 60s. Because of this, gap that took place because there was no recruitment, and even now you have fixed the number of people, young people trickling into laboratories. I can't imagine. I'm not inside, so I don't know.
Right.
But I can't imagine being more than 2 people, 3 people here and there. That doesn't. You need people to come in at the junior level, work, dirty their hands. They become useful after 2 to 3 to 4 years, and they have to be mentored all the way through.
Right.
And you can't lose that. And mentoring starts off when they're scientists Fs and scientists Gs, then they're able to mentor the youngsters also. But I think we think everything is information technology where you find so many 100,000 people in TCS. But even there, they are not working without a mentor.
Yeah.
Everywhere.
You need mentorship.
You need mentorship. You see Tata Engineering Services.
Right.
You see, there is a lot of talent in the country. There is a lot of human resources available in the country. But you got to start trusting our own people. You got to place more. If a financial irregularity takes place, which does take place in organizations, don't revamp the whole, put in so many controls that that bloody organization stops functioning.
Right.
So we need to be more prudent about these
Yeah.
things. All right, take him to task.
Right.
Take him to task very severely.
Yeah.
And in a very quick time. But for God's sake, don't spoil the system.
Right. Absolutely. So now, since you mentioned, sir, that we are actually, to use a Air Force term, we are short of runway length when it comes to the indigenous jet engine program. 8 years is what you're saying it would take.
I don't think
4 to 8 years?
for 4 years. I mean, the certification part itself
That will take another 4 or 5 years.
So I mean, total of 8 to 10 years.
So we are at least a decade away from seeing an indigenous jet engine.
Yeah, I think we probably see an engine all right. I mean, you keep working on the Kaveri, you will see. You will probably see a 72 kilonewton engine that can come early also.
Right.
But a proper developed 90 kilonewton engine, which I think the LCA Mark 1 will require. And no matter what TOTs we do or all that, I think systems have a life cycle of something like how many years? 30, 35 years? In our somewhere 40 years also. I mean, B-52s have been running for how much?
Yeah, the airframes have been running around
They're
for
running
quite a while,
around.
50,
You
60
keep,
years.
the systems only
Yes.
you keep changing, upgrading all the time. And that's going to be the trend in the future also. So if that is the case, I would in any case go and start these programs.
Right.
10 years down the line, I will require them.
By 2036, you will have your
3536,
engines.
I will have. I mean, I will require them no matter, even if for today's requirement, beg, borrow, steal, you need those engines.
Right.
But I think if we start programs today and fund them, and they'll be much less than any one aircraft deal that we make.
You mean the
The
imported?
total funding required.
The total
And provide so much of manpower in the country, build so much of capability in the country.
Right.
Even where a program does not succeed, in the human resource development part of it, we gain a lot.
Right. Absolutely. And how would you define success for all of these programs? I mean, would you say LCA Mark 1 flying with an indigenous engine, Mark 1A flying with an indigenous engine, Mark 2?
No, I would say as far as the aircraft is concerned, with a proper engine flying, I mean, I won't say LCAs which are flying now are not successful. They are successful.
Right.
A Mark 1A which flies will be a successful aircraft. But the long-term sustenance, if we look at it, as a matter of fact, our whole procurement system does not look at sustenance.
Over the life cycle of a platform?
Nothing. When you do a TOT, I mean, going by L1 doesn't solve your life cycle problems. All right. I mean, we have now started doing performance-based logistic in this thing. But that take you for 5 years, it take you for 10 years, and what is the cost you are paying? Yeah. And then you will have someone else come and do your maintenance also.
What is the, to your mind, sir, the single biggest hurdle that could derail this roadmap that you've outlined for the next 10 years? What is the biggest risk?
I don't know. It is the vision of the people who are going to take these decisions. I mean, I may not be correct, but whoever is taking this decision much will depend on the visions that he has.
Right.
Because his vision of the people who decided to go for a 124 kilonewton engine and not worry about, I mean, and leave this for TOT and import. Right. That's their vision. I differ with it. That's all. Maybe they'll turn out better than my vision. I don't know.
Right. But the vision thing is really
the vision.
important.
I mean, what's your vision? And the vision has to be based on some understanding of the subject you're dealing with. It can't be vision. Vision can be my. See, when I say Atmanirbharta, what is my vision on Atmanirbharta? Just manufacturing it over here? What is my vision? And then after every 5 years going and getting a re-TOT? So my vision is important. And I feel Atmanirbharta only comes when you design, develop, manufacture.
IDDM. That's
IDDM,
the sole criterion.
But for IDDM to succeed, The system to define your requirements has to be different. The system to develop from A to bring it to induction stage, and then somebody to look at when I'm taking it to induction state, what will be the sustenance requirements that will come on the way, and how will I plan for them? So, the easiest thing to do is TOT and a program, and then as we run the program, we understand the sustenance problems and keep solving them all the way.
Right. Absolutely. Thank you so much, Admiral Puri. It would be such a pleasure speaking with you. And as you've outlined, I think, and what you always repeat is that Atmanirbharta means Indian designed, developed and manufactured, IDDM. Without that,
I'm saying I don't want to say there should be an autarky,
right.
But I do say that design development, there are certain common use components that are available from multiple sources. I may not do it.
Right.
But there will be critical systems.
Yes.
In the whole game that I am working on.
Right.
For example, if I have got an aircraft, I must know the flight control system. For the engines, I must know where the FedEx is going to come from. Okay. I can sign a TOT, but the FedEx will be from that fellow. Right. The hot part will be from that fellow. And then every time I go, I mean, there are lots one can talk about.
Right.
What I have seen in my last, what my family says when I had my 80th birthday, they said, Dad, you are 18 years old with 62 years of experience.
On that note, Admiral Puri, thank you so much. It's been a pleasure speaking with you. One of the biggest votaries of IDDM Atmanirbharta, as always. It's so good to speak with you and to know about the roadmap for India's jet engine program as you've outlined for us. Thank you so much for being on Chakra.
Thank you. Thank you so much.